Awesome work on the first 2 lessons. You've made it to the last lesson of this course. At this point, you've generated your pairs, compared them, and scored them. Now, it's time to link your data. Remember our census data frames from the video of the previous lesson? We've already generated pairs between them, compared 4 of their columns, 2 for exact matches and 2 for string similarity alongside a 0.85 threshold, and found potential matches. Now, it's time to link both census data frames. Let's look closely at our potential matches. It is a multi-index data frame where we have 2 index columns, record ID 1 and record ID 2. The first index column stores indices from census A. The second index column stores all possible indices from census B for each row index of census A. The columns of our potential matches are the columns we chose to link both data frames on, where the value is 1 for a match and 0 otherwise. The first step in linking data frames is to isolate the potentially matching pairs to the ones we're pretty sure of. We saw how to do this in the previous lesson, by subsetting the rows where the row sum is above a certain number of columns, in this case, 3. The output is row indices between census A and census B that are most likely duplicates. Our next step is to extract one of the index columns and subsetting its associated data frame to filter for duplicates. Here, we choose the second index column, which represents row indices of census B. We want to extract those indices and subset census B on them to remove duplicates with census A before appending them together. We can access a DataFrames index using the index attribute. Since this is a multi-index data frame, it returns a multi-index object containing pairs of row indices from census A and census B respectively. We want to extract all census B indices, so we chain it with the getLevelValues method, which takes in which column index we want to extract its values. We can either input the index column's name or its order, which is in this case 1. To find the duplicates in census B, we simply subset on all indices of census B with the ones found through record linkage. You can choose to examine them further for similarity with their duplicates in census A, but if you're sure of your analysis, you can go ahead and find the non-duplicates by repeating the exact same line of code, except by adding a tilde at the beginning of your subset. Now that you have your duplicates, all what you need is a simple append using the DataFrame append method of census A, and you have your linked data. To recap, what we did was build on top of our previous work in generating pairs, comparing across columns, and finding potential matches. We then isolated all possible matches where there are matches across 3 columns or more, ensuring we tightened our search for duplicates across both data frames before we linked them. We then extracted the row indices of census B where there are duplicates and found rows of census B where they are not duplicated with census A by using the tilde symbol. And then we linked both data frames for full census results. And now that you know how to link data frames, let's put those skills to action.